happy to have you after this lunch. Hopefully you don't get drowsy. It's my job to be witty and entertaining for you. And well, I am not naturally witty and entertaining. I am very concise. I am told I am quite concise. So feel free to ask those questions in chat in case I gloss over something that you want to know more about. All right. So my name's Dr. Paul Steen. I work with the Huron River Watershed Council. The bigger part of my MiCorps work involves doing all the stream side, the stream monitoring, but I have been involved with lake monitoring since I started here 15 years ago, and I help out by doing the chlorophyll presentation and training. And then the other part of my role with the Lakes program is looking at all of your data at the end of the year. So I do a lot of quality assurance checking. I do a lot of data crunching, data analysis, data visualization, stuff that is really neat. And I get a chance to look at everything that you guys come up with. So happy to participate here. And this is the chlorophyll training. Here's what we're going to cover in the next hour. What is chlorophyll? We'll talk about the sampling schedule. We'll talk about the two pieces of the sampling, water collection and sample filtering. And then this is also in this presentation is a good chance to talk more about the data that we will have at the end of all of this, since that's my specialty in the program. So first of all, what is chlorophyll and why do we measure chlorophyll? Okay, so chlorophyll is probably the best way we have to get at the algae levels in your lake. And that is because chlorophyll is in every algal cell, green algae, blue-green algae, that all contains chlorophyll. And chlorophyll is a molecule that is used to convert sunlight into usable sugars for the plant and algae included in that, to be able to live, and then it provides those sugars then provide the base of the food web for the entire lake. So Eric talked quite a bit in his presentation in phosphorus about algae, because the question of is algae good or bad for your lake, and the answer is it depends. Every natural system is going to have some amount of algae in it. If it didn't have anything, it wouldn't be too much dissimilar than buying a jug of distilled water from the grocery store, and not very much could live in it. These natural systems need algae to keep everything else in it alive. So, but then you have the issue if there's too much algae. If you go hyper-eutrophic, you can run into dissolved oxygen issues. It can cause fish kills. So the answer is every lake is just a little different in what that natural the natural levels that exist in it, and then humans have the ability to alter that one way or the other. All right, so I'm gonna go, just as a reminder, if you're not muted, please do so. Or Eric, if you could run down the list and make sure everyone's muted, because it throws me off a little bit when I hear that in the background. I got muted. Okay, all good. How we use chlorophyll in the data is as part of this trophic status index. So combined with transparency, combined with phosphorus, chlorophyll puts us on the spectrum of the lake's productivity. And we will know if your lake is oligotrophic, low in nutrients, eutrophic, high in nutrients, anywhere in that spectrum in between. And the hope is that then you can use that information to make proper management decisions for your lake. So let's talk about how to sample for chlorophyll-a. Essentially, it's sampling for algae, which then in the lab, they pull out the chlorophyll-a molecule and give us a number that reflects the amount of algae. So there is a sampling schedule that you should all have, and if you, it will come with your equipment when you register for chlorophyll. And then if you don't have it and you need a version that you can look at, you can always go to our website here, then you MiCorps.net, then you go to lakes, and you go to CLMP documents, and you'll be able to find this document. And it looks a lot like what we have for phosphorus monitoring, all right, which means on the left-hand side, you'll be able to find your county. There'll be a place where you are going to be bringing your sample along with a contact information for the person at the office there who's in charge of receiving the sample. And then the fourth column here is the sampling dates, and this is what I kind of want to highlight right now. You'll see that there are samples 1 through 5 that we want you to take, and each of those has a specified date. And generally, samples 1 through 4, it's going to be during the middle of the month, from the 10th to the 20th, and you do that from May, then June, then July, then August. So somewhere between the 10th and the 20th of each of those months, you should be making this measurement. Typically, it will be the same time you're going out and taking SecuDisc. So just do it in that window, get it all done at the same time. Now, sample 5 is different. That it depends on the date of your summer phosphorus, and it's different depending where you are in the county. The more southerly counties in the state will have it closer to the end of September, while the most northernly will take that final sample usually at the end of August. We always call that the September sample, no matter when you take it, just so if you see that, you don't get confused by our terminology there. But so anyway, this document is out there for you to just be reminded of when you're supposed to be taking those samples. Now, one thing you'll see there, you have this dotted line that's dividing 1 and 2 and 3, 4, and 5. That's because what we're doing is we're taking samples 1 and 2, and then you turn those in along with the spring phosphorus. It all happens at the same time. And then you'll be collecting samples 3, 4, and 5, and that will be turned in the same time you turn in your summer phosphorus sample. So you should only have to make 2 trips to your drop-off point in the summer. And we also divide the data form up. So you'll have a data form 1, which handles the May and June samples. And you'll have this will say a data form 2 that does the other 3 months. So other than that, it's kind of very similar to the other data sheets we have. We want you to fill out the lake name, the county, the township, the field ID. Remember, Eric mentioned every lake in our state will have one of these field ID numbers, your latitude and longitude, your name, and then when that will just be generic for your lake. And then when you actually go out and do the sampling, you'll fill out all of these sections for that particular day. And we'll kind of talk about some of these blanks as we go along in the training. Now, one very important thing in chlorophyll is we ask you to get 4 or 5 of the samples throughout the course of the summer. That is your goal. And if you don't, then we end up not being able to include that information in your long-term graph, in your data summary that you eventually get. So we always ask for 4 or 5 samples. And the reason we ask for that many is because just like with SecuDisc, these levels will change over the course of the summer. So different things are happening in the algae community over time. In the spring, we'll often have peaks of diatoms, which is a particular kind of algae, because the lake is turning over. Brings up nutrients and silica, most importantly, which goes into their cell walls, and that's when the diatoms bloom and do very well. As all that is used up and as the temperatures begin to increase, we'll see more of green algae coming into your lakes, and that population will flourish. Then in some lakes, but not all lakes, toward the end of the summer, you'll see more and more blue-green algae, cyanobacteria, because they do better in warmer waters. And then in the fall, the diatoms come again when you have another turnover in your lake. So the algae community is constantly changing, and it wouldn't be accurate to get all your samples done in one half of the summer without getting the later half of the summer. So that's why we have this requirement. You have to get at least 4 of those months. If you simply cannot because you're out of town, then you need to have a neighbor get that, have them go out with you and show them how to do it 1 month so that they can do it the next month. It's of course best if you do it as the trained person, but it's still, we do want you to get those 4 samples or 5. So don't be one of those people that only gets 3, and then I feel really bad when I fill out your report at the end of the year and I can't include your data. It always happens, and I hate when that happens, so that's why I'm making such a long-winded speech about it. All right, so let's keep going here. All right, so chlorophyll equipment. I'm going to stop sharing a second because Eric is going to help me with this part. And I want you to be able to see Eric's face. There he is. And because I forgot all of my equipment that I was supposed to have and to show you on screen. And Eric has it all. So he is going to kind of show off the different pieces. And I think the most important thing, Eric, I want you to show them is the 60 milliliter syringe. So go ahead and pull up the 60 milliliter syringe. Eric has attached to that, or he did, the filter holder. Go ahead and show that. Now, when you get this, the first thing you'll say is, hey, this filter holder does not screw onto the syringe. And that's okay. That's by design. They weren't built to work together, but they do. So you don't screw it on, you just kind of push it on when you use it, and it's a nice tight fit. Yeah, nice, Eric. Nice close-up. That's much better than they get in the live training. Now the other kind of trick to show you with this is the filter holder. So Eric can take off the filter holder, and you can unscrew this thing. That's a key step. Inside you will have an O-ring, like a little gasket that's used to maintain a watertight seal. So don't lose that thing. You will need it. If you don't have it, it won't work. And then what you'll see later when we watch the video is we'll put a filter right on that, then we'll put the O-ring on top, and then it gets screwed back together. So that this is the contraption where that you're actually doing the filtering through. Yep, just like that. That's great. Okay, the next thing, Eric, maybe you can show them is the Tygon tube. And this is kind of the same deal. It doesn't really fit with threading onto this syringe. It's kind of a jam and push situation, okay? It fits nicely. It's a nice, tight, snug fit, but it's not meant to be screwed on, okay? So it's just good that you guys know that. It takes pushing and a little bit of muscle to get that on nicely. So those are the things I wanted you to see nice up and close, because when you get your kit, those are the questions that often come up. You think it's not working right, and it is. This is all how it's designed. This is how we've been doing it for 20 plus years with great success. It's a homemade system, bits and pieces as we can have found over time. So, all right, you can shut down, Eric. I'll go back to sharing my screen. Let's see. All right, I'll go back to sharing my screen, and I'll say from this slide. Okay. There's some other things that will come in that kit in the mail, or you maybe already picked it up at the conference. We'll have lots of little filters in a baggie, which I'll show you a picture of in a second. There'll be vials that where you put the final filter after you do that work. There'll be amber bottles that your sample goes into when you are out on the lake. A dropper bottle that has it's labeled as MgCO3, magnesium carbonate, and that's a chemical we use to stabilize your sample. It will come with Ziploc bags, which you use for your turn-in. It will come with labels that you'll put on your vials and the clothespin. So we're kind of going to show you all of this stuff in action as we go. But it's important when you register in this program and you get your equipment that you kind of look through, make sure none of these pieces are missing, okay? So you can refer back to this slide, make sure you have everything. If for any reason you lose something's not included, you can always reach out to us, Gene Roth specifically, and we'll get you the pieces that you need. Now, the other thing that you get when you register for chlorophyll, I'll come back to that, is the actual sampling device. So this thing is designed for you to connect to a measured line and lower it into the water. Its functionality is such that here at the cap, you have water entering in at the same time that air is coming out, because there'll be two glass tubes coming off the top. The whole thing is held together by this system of chains. This retaining chain goes around the mouth, and when you want to take it apart to dry it, for example, so the whole thing doesn't rust out, it's important that you first take off the cap, take off the rubber stopper, and then you can take this retaining chain off and disassemble the whole thing. Sitting at the very bottom of this sampler are weights, and the weights are not glued in, they're loose, so as soon as you take this amber bottle out, it will certainly make it so that these weights can come out. And you do want to do this after every time you use it to dry it. You want to take it all apart, let it sit on the kitchen counter, and so it doesn't rust out by the end of the sampling year. But the result of all of that is sometimes people drop their weights overboard. So just beware that they are not in there permanently, all right? Okay, going back, the other issue that can come up is when you use your filters, and this is be referenced over and over again in this presentation, is that you will be given this baggie of filters, and you'll have all these circles in there, and there's white ones which are opaque, and they kind of look like almost like a plasticky material. Okay, and then you'll also have blue circles that look more like tissue paper. It's very important that you always throw the blue circles away and do not use them. They are separator sheets that are used to keep the filters from sticking to each other. That's why they're in there. But if you use them as a filter and actually try to run a sample through them and turn them in, it won't work, and we'll have to end up rejecting your sample. So remember, blue equals bad. Throw them away, don't use them. And the reason this throws people for a loop is because your natural instinct might be to think that the blue ones are the ones you're supposed to use because they're kind of translucent. They look like tissue paper. They look a little bit more like what a coffee filter would look like. So that's why people think they're the ones you should use. But it's actually these opaque ones that are the actual filters. It's because the pores are so small that you can't see them, and it just looks like a little circular piece of plastic. So don't go with your instincts on this one. It's these white ones that you want to use. Now you may order what's called a resupply kit. And the people who do that are ones who've already been in the program. So when you order a resupply kit, the only thing you're getting are these 5 things here, because these are what are used up every year. All right, so you don't get the big sampler. You don't get some of those other items that we kind of went through, because those are meant to be reused over and over and over again. But every year when you register, you do need these consumables. This is a little bit cheaper to buy. So oftentimes that's what people, that's what you want. Now, it's also important to note that returning volunteers, if this is you, don't use old filters. Throw out filters at the end of the year that you haven't used. You'll see we often give extras in case you drop one or lose one. That means some people over the course of 5 years save up enough to actually use them for the next year, which we don't want you to do, because filter technology is changing, or we're changing suppliers. Sometime in a few years back, we ran into an issue with we had some bad filters, and we don't want those circulating around and being reused. Okay, so always get rid of your old filters. Just use the new ones for that year, so we know that everyone's on that equal playing field for the year. There's a few things you need to provide. You'll have to, we want you to have life jackets out there, so does the law. You need an anchor to get in position. You need a pencil or a Sharpie, something that won't run in water, to write your data sheets and your labels. The equipment needs a measured line. So the measured line is something you provide. It can just be a standard nylon rope that you use for other boating uses, and you ahead of time measure every foot, probably up to about, depending on the depth of your lake, it might be 40, 50 feet every foot. And so that's ready to go, and it's attached to your sampler. You'll also want a freezer pack with ice, because we always put things on ice after we take the sample. And then in the lab, your kitchen, you will need a small amount of aluminum foil, which will show you why as we keep going. Okay, so let's see what time it is. I'm sure there's questions. I see they're there in chat, but I better keep going because I don't want to run out of time. So
yep, you're doing good, Paul.
Okay, yeah, as always, if we don't get to your questions, you can always follow up with us. Okay, so sampling is step 1, getting a depth integrated water sample. Remember, there's 2 parts to doing chlorophyll, and this is the first. So you're heading out onto the water. Like any of your parameters, what you want to do is anchor upwind and let the current or the wind push you onto that deepest point on your lake. Now, it's not 100% mandatory that you're at the exact right position, but you should just be in the pretty close to the general area of where that deepest point is. And the reason you don't motor right on through it is because we're trying to keep the water from being disturbed as you start your monitoring. You can start to fill out your data sheets at this point, the whole top section, weather and your location and all that stuff you can start filling that out. And then you take a SekiDisc. So you're probably doing this already if you'll be enrolled in the SekiDisc program. But the chlorophyll sampling actually requires a SekiDisc measurement to be made. So just as a reminder of how to do that, you don't wear sunglasses. You try to do it in the shady side of the boat whenever possible. And you lower that disc down. You wait till it disappears from view. You mark that measurement. You raise it up. You mark that, and then you take the average of the two. And that is your Secchi disk depth. And the reason that's important is because you want to drop your chlorophyll sampler to twice that Secchi disk depth. You can see in the little graphic here, this fisherman got a Secchi disk of, let's say it's 10 feet. He got a Secchi disk of 10 feet. So then he's going to drop his sampler down to 20 feet. And the reason for that is because light penetrates twice the Secchi disk depth. And so all of this portion of the water column, that whole 20 feet, is called the photic zone. And that's the zone of the lake in which you have light, and that is where algae will be growing. So the goal of our sampler is to get water from that entire length. That's why it's called the depth integrated composite sample. Little drips of water will be coming into your sample as you pull up this thing from the bottom to the top. So you have a representative sample of all of that water. And then there's a spot on the data sheet for you to record this. There's a spot for your Secchi depth. There's a spot for you to record the sample depth, which is twice that. And of course, this begs the question for many people, I can't go 2 times my Secchi depth. My lake isn't deep enough, or sometimes my Secchi itself is at the very bottom, so of course I can't go any further. Yep, totally normal situation for many lakes. So what you do in that case is your composite sample is the full depth of your lake, minus 1 foot. And the reason we don't want you to go to the very bottom is because we don't want you dropping your sampler to the bottom and causing a big little, well, not a big, but a muck explosion, and then you're taking in muck into your sample. So we never want to hit the bottom of the lake with our sampler. So you stop it a foot above, so that's not an issue. All right, and then still record the actual depth at which you're doing this, then not twice the Secchi. It's what you're really actively measuring from. Okay, so once you do that, you figure out your depth. Now it's time to get that actual water sample. So you take your sampler apart, you have to take off the lid, you have to take off the rubber stopper with the 2 tubes coming out of it. You take off the retaining chain, you disassemble it, and we're gonna rinse the amber bottle with lake water as the first step. So you're actually just disassembling this whole thing. Don't drop your weights overboard at this point, because they're just lying in there loose, remember? Okay, then you'll reassemble the sampler, and you are going to, with a clothespin, mark your composite sample depth on your rope. And that's because when you release this thing, as soon as that clothespin gets to the water surface, then you know you're at the right depth for how far you're supposed to go down. So basically the clothespin just notes that depth ahead of time. Yep, so that's kind of just a nice little trick there. So you do that, and then what you're actually going to do is release the sampler and just let it free fall down to that depth. You might want to just have a hand on the rope and let it slide through your hand so you can stop it when you need to stop it. But the idea is that you're getting it down to that bottom point as quick as you can. Once you do that, you bring it up at a slow, steady rate. And what that slow, steady rate is just depends on how deep you went. And it's something that you'll just have to figure out for yourself. If you only drop your sampler 10 feet, you probably have to do it very slowly. If you dropped it 40 feet, you may have to do it fairly rapidly. Because remember, the goal is you're getting water in your sampler from that entire that entire water column area. So the way that check that to make sure you did that right is that when you bring it up, you open up your bottle, you look in it, and if it's completely full, then you have to redo it because you were probably pulling too slowly. And you don't know when that water bottle filled up. It could have filled up at the very bottom, for example, if you were pulling too slowly. So dump it, redo it, pull up faster this time. If it's really empty, it probably means you were pulling too fast. So dump it, redo it, pull slower this time. And the goal is to get your bottle 2/3 to 3/4 full, and that will be enough water for you to do the next steps successfully. So you disassemble again, take your big amber bottle, give it some gentle swirls or inverts, nothing too harsh, too rapid, because you're trying not to break apart all the algae that you just sampled. And then you will have 2 rectangular amber bottles that will be significantly smaller than your big liter bottle. And you fill up both of those. You actually fill up 2 bottles because you are going to take two samples in the course of this sampling. So you can see there's a good example. The guy's using 2 amber bottles. At this point, you take your magnesium carbonate and you add 5 drops to each bottle, swirl it, or gently invert it to mix that magnesium carbonate into the sample. And what that does is it stabilizes the chlorophyll molecules in there, keeps them from breaking apart, because our goal is to get those onto the filter paper in the next step, without smashing all the pieces apart. Okay, the pieces of algae that you have in your sample. And then this is why you have a cooler pack. Put everything on ice, or at least a cooler to try to slow down the biological productivity. And then you'll go back to your house, because the next step is done in your kitchen. So I'm going to show a little video on this next part because it's just kind of easier to see it. This is a video any of you can get to at any time. There is a particular YouTube, but don't try to copy that down because I'm going to show you just how to get to it on our website, which will be a lot easier to remember. So actually, I'm going to exit out of the PowerPoint. And I think I have to stop sharing, and then I'm going to reshare because I screwed up the settings. I have to make sure the sound comes through. So let me do that. Okay. All right, so you should be able to see that again. And I'm going to go to our website. This is good for everyone to see anyway, to know how to do this. So we're at MiCorps.net. And then in here, I'll just mention it since I'm here. Anytime you need a document pertaining to one of the parameters, go here, Lakes drop down, then CLMP documents, and it will have all the data sheets and the schedules and that sort of thing in there. You can also go to Lake Training, which is what we're going to do. And this is probably how you registered for the conference in the first place, or this training. This is where we'll put all the recordings from this. Right now it has last year's. We'll put on this year's when it's done. But keep scrolling down, and now you get to our video. So we have a video for each of these parameters that we're going through. Here's Secchi-Disc, here's phosphorus. Okay, and here's chlorophyll. So I'm going to play the filtering part of this. I'm going to make it big.
This video reviews.
And it starts at about 5 minutes and 50 seconds. All right. All right, so we're going to start there, and then I'll come back when we get through the filtering section.
The best place to filter a chlorophyll sample is indoors, by a sink, and out of direct sunlight. Make sure you have all of the equipment listed. Ready to go? First, unscrew and open the filter holder. Use tweezers to pick up and move the filter. Never use your fingers. The filter is a glossy and opaque white circle. Be sure not to use the filter separators, which are translucent and look more like tissue paper. Center the filter on the screen and place the O-ring on top of the filter. Screw the filter holder back together until it is moderately tight and place it to the side for the moment. Grab the syringe and the small piece of clear plastic tubing. You can push the tubing onto the syringe. It doesn't fit perfectly, but it will not slip off if you work at it. Swirl or invert one of the amber bottles to mix. Rinse the syringe by drawing up sample water until the syringe is full, and then empty it. Then, fill it up to the 60 milliliter line. With the syringe pointing up, tap it to force air bubbles to the top. Push the syringe plunger until the end of the plunger is lined up with the 50 milliliter mark. Attach the filter holder to the syringe. Like the tubing, it won't snap into place, but you can get it to fit snugly. Slowly push the chlorophyll sample through the filter holder and adjust your pressure to achieve a rapid drop rate. Pushing too hard may rip the filter, so avoid excessive pressure. As you push the plunger, make sure that no water is leaking out the side of the filter holder. If your sample has a lot of algae or other particles in it, it may become too difficult to push the full 50 milliliters of sample through the filter. In these situations, stop pushing and note how much water you were able to filter by reading the side of the syringe. There is a place on the datasheet for you to record this information. After filtering the water, separate the filter holder from the syringe and unscrew it. Using a safety pin and tweezers, fold the filter in quarters with the algae on the inside. The filter will probably stick a bit to the filter holder, and it requires a steady hand and some practice to do this job smoothly. Remember, never touch the filter with your fingers. Put the folded filter into a sample vial and cap it. Place a filled-out sample label onto the vial lengthwise so that none of the label is wrapped upon itself. Let's take a look at what a correctly filled-out sample label looks like. You need to use a fine-tipped, permanent black marker to fill out the sample labels. In addition to the basic lake information, write Ca in the parameter code box and write MgCO3, which stands for magnesium carbonate, into chemicals added. Remember, you added magnesium carbonate in an earlier step. On the label for your second sample, write REP next to the lake name. This is short for replicate. You now have one sample complete. Congratulations! Now you get to do it all over again with your second sample bottle. Once both samples are complete, wrap the vials completely with aluminum foil to keep all light out. This foil wrapping step is critical. Unwrapped samples cannot be accepted for laboratory analysis. Write your lake's name and the sample month on the foil packet. The samples go into a Ziploc bag with your lake name, county, and field ID number. Fold the data sheet, place it into a separate Ziploc bag so it stays dry, and place it in the bag with your samples. Storing your data sheet with the samples is a good way to make sure the paperwork never gets lost. And then everything goes into the freezer until it is time to turn it in.
Okay, so that's that. Let's exit out of there, and I'll bring my PowerPoint back up. Okay, so remember, this is how you get there. It's just really helpful to have that over the course of the summer, because there is a lot of steps. So we also have written directions too, if you prefer that method. Okay, so just to highlight one thing in that video, if you have a lake that has quite a bit of algae in it, it may not be possible to filter a whole 50 milliliters. It's because the filter will start clogging up and you'll be pushing that syringe and it just won't want to go through anymore. And it's better to just stop in those situations, because if you really use all your muscle, you might end up just blowing the filter apart into pieces or rip a hole into it, and then you'd have to redo the thing anyway. So it's very easy to just stop at a point in which the filtering gets too hard, and you know how many milliliters or cc's you actually used in that filtration process, because the lab is able to correct for that and proportionally put up your amount, your final results. So anyway, this is where you record that, and there's a sample 1 and the sample 2, because you have that replicate sample that you're doing. And then it's time to turn it in. Make sure you make copies of your data forms. Nowadays, it's very easy to do that just by taking a picture with your phone of your data sheet. Usually those are very high resolution. It will show everything nicely. And then you turn in your original data sheet with your sample. You keep everything frozen. Just as a reminder that the sample turn-in's the same day as you're turning in your spring or summer phosphorus. You just bring it all to that point at the same time. And then you need, we appreciate you entering your field notes. So the date you went out and the weather and your depths and all those pieces that you recorded on your data sheet. There's a place on our website for you to enter that data. And I think I'll just show you really quick, because it's super easy to do, but if people haven't seen it before, it might just be a little confusing. So let me just go back to our website. So once you're here, you want to go to Data Exchange, and you can see the drop. All you have to do is hover on this, see the drop down, enter data. Okay. Now my view is going to be a little different because I'm an admin, but I'll get to your view really quick. It should look like it should look like this when you say enter data, and it will list all the sites that you have access to. I see all the sites in the program because I'm an admin, but for you it will probably just have 1, 2, 3 lakes in here, and you just click the lake that you want to enter data for, and it will say all the information about your lake on here. And then you just scroll down and you can see a spot. This is where you can click on to enter data for any of those particular parameters. So it's that easy. Then it's just a matter of filling out fields that match your data sheet. So we do appreciate everyone who's able to enter their own data in that way. It saves a lot of staff time on the program side. So it's wonderful when you can do that. Okay, just as a reminder that this exists, here's the turn-in dates. Whoops, the turn-in dates for our samples for this year. Keep going. Sometimes your samples get rejected, and it's important to know what these issues are so you can avoid them. If you don't collect your sample at the right time, you're outside of that assigned interval, they will be rejected. Okay, so sample it as the schedule says. If you don't filter it on the proper filter, it will get rejected. So if you're trying to filter it on the blue separator sheet, that will mess up the results and it will have to get rejected. You have to wrap your samples in foil. It doesn't have to be like 3 feet of foil, you know, but maybe like this much. Okay, enough to fully wrap those vials because you don't want any light getting in and touching the filters because that's going to affect the chlorophyll that's on the filters. All right, so those need to be wrapped up like you saw in the video. And the last thing is incorrect delivery. So if for any reason you cannot follow the normal expected procedures of how to turn things in, we need you to contact us to get instructions on how we want you to get the samples to us. Don't go rogue and just kind of do your own thing. Inevitably, that samples will get lost, samples will thaw, and we'll have to reject them. So if you can't follow normal procedure for whatever reason, that's when you need to contact us directly, and we'll figure out how to get your samples safely. Okay. Just thinking about how's our questions. Eric, are you able to get most of those in chat?
Yep, there's just 1 or 2 that you'll have. So you're around 11 minutes left.
Okay.
So
I'm going to cover the next. Yeah, I think I'm going to cover the next part before we do questions because I want people to be able to see that. And that's that. At the end of the year, sometime in March, early April, you will get a report that reports out on every bit of data that you have collected. It looks, sorry, I'll go back to those. It looks like this, all right? So, and not only is it this year's data, but it's all the results we have on your lake since anyone has been monitoring this lake in our program. So there'll be a section on Secchi disc, a section on chlorophyll, phosphorus, dissolved oxygen. There'll be summary information that tells you what your trophic status index is, oligotrophic, mesotrophic, eutrophic, that sort of thing. Your report will also have full-sized graphs of everything that you have done. It will have all of your dissolved oxygen and temperature profiles. Any score the shore or aquatic plant results for any year that you've done it will all be in this. And I make a lot of these, so I definitely can make some mistakes. So here's my email address, and I'm pretty good at trying to turn those around if you find mistakes, because I know a lot of you present this at your lake annual meetings, and you might be under a deadline. So I do try to make that a priority of fixing things if I'm the one that messed it up. So just to go, if we were to zoom in on one of those boxes a little bit, what it will do, this is 2019, but it will list the most current year. And chlorophyll, for example, this lake, they got all 5 of their samples done. They ranged between 1 and 5.2 parts per billion of chlorophyll in their samples. The median is 2.2, and this is the number that we graph down below. You can see how this lake has, over the course of the last 20 years, has progressively declined in the amount of chlorophyll that they have found. So their lake is turning from what looks mesotrophic into something that's a little more oligotrophic, though it bounced back in the most recent number. And we'll have like windows. Here's the last 5 years that have been on this lake, the last 13. So it shows the old history. And then a comparison of every lake that's been in the program for this particular year. So this lake is actually right on the median for all lakes that have reported. So if you wanted to know how other lakes are doing, that gives you that information. I'm going to keep going. So trophic status index, what that gets at is taking the SECI and taking your summer phosphorus and now taking your chlorophyll and averaging those results together to give you a number that puts you on this trophic continuum. Now, none of these are like comparing apples to apples. They're all on different scales, right? SECI depth is measured in feet, and summer phosphorus is measured in parts per billion. So Carlson, or the reason we call it Carlson's TSI, scientist Carlson developed these equations that can convert those numbers into numbers that are comparable with each other, puts them on the same scale. And then you end up with what essentially is a thermometer, but it's a thermometer of nutrient production. And so everything ranges, these numbers will all range somewhere between about 30 and 65. And you can graph out your scores for the various parameters to see how they're doing. Generally, they will be fairly close to each other because they're reflections of the same type of thing in the lake. And then you'll have your final average. And if you're at, for example, this lake is at 37, that puts some oligotrophic, kind of in between oligotrophic and mesotrophic, leaning a little bit more oligotrophic. So we like to put things into categories, but the reality is the nutrients, this is a nutrient spectrum, and the most accurate view is actually this one, and not just saying something's oligotrophic or mesotrophic. It can fall in this continuum. So the hope is that this information, these reports, can help you report out to your community and have a better understanding of issues going on in your lake, things that you may need to address with your neighbors, like trying to cut down on fertilizers going in if you see your nutrient levels increasing over time, that sort of thing. All right, so I do have a few minutes for some questions, so I can bring up the chat and see, or Eric, if there's anything that you know that I can address that you haven't covered yet.
Yeah, so I'll read one from Jim. So this is in regards to the 50 cc's of lake water. So you are actually counting bits of algae per 50 cc of lake water, or bits per less than 50 cc of lake water?
So it's a 50 cc. Counting bits is probably a simplification. I don't know the exact laboratory procedures, but what they do is they take your entire filter and dissolve it in some sort of chemical, and they do an extraction, and it's probably, I don't know, maybe a spectrophotometer use or something, and from that they're able to get a parts per billion number that they report to us. So it's not that they're actually like counting algae cells, but they're dissolving it all in a procedure, that the standard procedure that they use at the lab. But it is 50 cc's, and they do that, so it's always a standardized amount, which is needed to make sure you're always comparing the right things to each other across the whole program.
Thanks, Paul. Are there any other questions?
I have a question. So I'm a first-time volunteer, and I see that like the Secchi discs and the tests are for sale on the website. Is that something that we have to pay for, or is it included as being a volunteer? Or
Yeah, if you start going through the enrollment process, you'll see the full cost breakdown as you do that. There's a cost to enroll into the program, and then there is a cost for equipment. And the reason we separate those out is, for example, if you're a longtime volunteer, you're not going to need to pay for a new Secchi disc every year. That would be a one-time purchase. So those are itemized in the enrollment process. Oh, great. Thanks, Joe. Joe just put in chat particularly the costs without having to go through the enrollment process, I think.
That's right.
It's just listed there for you.
I have a question.
Go ahead,
Go ahead.
Dan.
Yes. What would be the longest that you would want to hold a sample between collection and the actual filtering? In case I'm going to be out of town on sampling day, but not really trusting the collector to do the filtering.
I don't know. Joe and Eric can chime in because I don't know what our SOP is there.
So as a normal standard would be within sampling or filtering within 24 hours of collection.
Okay. All right.
Yeah, and if like you said, if you're going to be gone for one of like the weekend, maybe we do have the window for sampling is multiple days, so maybe you can shuttle it around and find a day that works.
No, unfortunately, I'm going on a river cruise the week of July.
Sounds unfortunate.
Yeah, really tough.
We do. There's flexibility there. So in terms of sampling and not sampling. Remember, I said there's 5 months, and you have to get 4 of those months. So, like, if circumstances beyond your control have you missing a single sample, that is within our protocol. Just don't miss 2. Okay.
Perfect. Richard in the chat says some freezers have a defrosting cycle. Does this affect the integrity of the samples we collect?
The samples those filters have to stay frozen, or biological productivity will, it will possibly the algae will continue to grow on the filters. So I don't know freezer engineering.
I'm guessing, yeah, with the defrost, if it's not touching, same here, Paul, about the how freezers fully work, but I think if it's not up against the wall of the freezer when it's in its defrosting cycle, it doesn't thaw, it shouldn't thaw enough to, the defrost shouldn't be enough to thaw your stuff in your freezer.
Yeah, I mean, it doesn't thaw other foods in your freezer, I would imagine, so it should be okay.